something will have been passing through your mind. Like, that's for products. How do you do it for division? That's where quotient 2 comes in. Quotient 2. In quotient, you have expressions like this. Y equals to U, V. And U and V are in X. Are functions of X. Now we have Y equals U over V. And then when there is change in X, there will be change in corresponding change in U, delta U in U, and delta V in V. So everything will combine to delta Y in Y. So we are going to have Y plus delta Y is equal to U plus delta U over V plus delta V. You get that? Let's call this equation 1. And then Y equals U over V. Let's call this equation 2. And we also know that U and V are functions of X. Now let's subtract 2 from 1. We are going to have delta Y equals U plus delta U over V plus delta V minus U over V. You can see. Now, we are going to have UV plus V delta U minus UV minus U delta V over V squared plus V delta V. That's the expansion. Therefore, this one we cancel this. I'm going to have delta Y is equal to V delta U minus U delta V divided by V squared plus V delta V. That's what I'm going to have. And I want you to note something. That when delta X change in X tends to 0, delta U, delta V, delta Y tends to 0. Delta U, delta V, delta Y tends to 0. Note that. At the same time, delta Y, delta X will tend to dy dx. Delta U, delta X tends to du dx. Delta V, delta X tends to dv dx. You can see, very simple. So I told you what our first goal will be. Getting change in Y to change in X. So let's quickly do that. Let's keep this notion to ourselves. We are going to have and that's going to give us V delta U delta X minus U delta V delta X divided by V squared plus V delta X. Now, if you bring 0 to this place, you know this one will cancel. This place will be dv dx. This place will be du dx. And this place will be dy dx. So, therefore, dy dx is equal to v du minus u dv over. So you can see, when you have quotients like this, it's going to be the denominator multiplied by the differentiation of the numerator minus numerator multiplied by the differential of the denominator divided by the denominator squared. So this is the formula. Straightforward. Do a build up to something. Okay, let's do something like this. Y equals to 1 over x plus 4. Let's find the y of the x of this. So we are going to have equal to 1 equals to u, x plus 4 equals to v. So we are going to have v du. What is du? Du dx is equal to 0. dv dx is equal to 1. So what is du dx? 0 minus u dv dx divided by v squared. This is 1 over x plus 4. Simple. I'm trying to build up to something. Now let us now look at the expression like this. This is number 1. Y equals to x plus 3 divided by x plus 2. Let's see what the differentiation will be like. dy dx will be equal to v x. Okay, let's do it. U equals x plus 3. Du dx is equal to 1. V equals x plus 4. dv dx equals to 1. Now, dy dx will be equal to u n v, sorry, du dx 1 minus v x plus 3. Sorry, v du dx minus u dv dx divided by v squared. Now what does that give? X plus 4 minus x minus 3 divided by x plus 4 all squared. What does that give me? 1 over x plus 4 all squared. 1 over x plus 4 all squared. Sorry. This one is minus 1. This is minus 1. And this one is 1 over x plus 4. I'm trying to bring about something. Now, dy dx for this one. We can also express this one as x plus 3 into x plus 4 raised to the power minus 1. Remember? And I have done this one just so that I can use it here. Please. So, I'm going to put this result to use. So, dy, let's x plus 3 be u, and x plus 4 raised to the power minus 1 be v. Let it be v. Now, the u dx is equal to 1. The v dx is equal to minus 1 over x plus 4 raised to the power minus 2. Please, raised to the power 2. From here, please. I'm trying to bring about something. Yeah, I am trying to use product rule so that we can compare with this one. So, dy dx is equal to, what is our u? X plus 3. What is dv dx? Minus 1 over x plus 4 raised to the power 2. What is our v? X plus 4 raised to the power minus 1. What is our du dx? 1. You can see. Now, I can now write this as x plus 3 over x plus 4 all squared. And this one is minus plus 1 over x plus 4. You can see what I'm getting now. And I'm going to have minus x minus 3 plus x plus 4 divided by, you know this is the LCM, x plus 4 squared. X plus 4 raised to the power 2. This one we cancel this. So at the end of the day, I'm going to have 1 over x plus 4 raised to the power 2. What I'm trying to achieve is this. For you to know that this quotient rule is real and is practical, I am trying to do this one working with the quotient rule, and I now use the product rule. Now you compare the result of the product rule here and this one, you can see they are the same. So once you see a quotient like this, you can quickly put the quotient rule to use. And if you like, you can express it as products, depending on you. So you can do some practices later on. If time permits me, I will do some exercises. Now, before I do this, I would like to do what we call function of function. Here we apply chain rule. Now, let's talk about function of function. You know, when we have expression like this, y is equal to a function, are you getting it, of another function of x. Or let me put it like this, g. This is a function of another function of x. Do you understand? So, how do we differentiate this? That's what we are talking about. Like, we are having it like this. Y equals to sine x squared. You know, this is something that needs to be differentiated. Sine x itself, although we have not done that of trigonometry. So, okay, you can have something like this. Y equals to x plus 3 all squared. How are you going to differentiate this? It's very simple and pretty straightforward. We apply what we call chain. And that is going to be something like this. Something like this. Y equals x plus 3 raised to the power 4. You know, if we want to do this, we might need to be doing expansion, which will be involving x and 3 multiples. If it had been, if we had y equals x raised to the power 4, this one will be easy to handle. For this one, we will need to do expansion and expansion and expansion. So instead of that, what do we always do? We will write it like this. Let u be x plus 3. Therefore, y will now be equal to u raised to the power 4. You can see, very easy. Under differentiation, everything is very easy. We will now do this. dy dx, because that's our ultimate search. Dy dx will now be equal to dy du times du dx. That is the chain rule. You can have it to be in any form. All you need to do is to make what the other function inside the function, you will represent it. You know, this is another function now, u raised to the power 4. So you will represent it by putting the expression to be equal to one small, function, and you differentiate y with respect to that one, that is dy du in this instance, and then you now differentiate that one inside with respect to x. It can be long. It can be dy du times dv du times du dx. It depends. So it's very, something like fun, creativity. Just bring it in and you get your answer. You get your results. Now, like this one now, I have dy, y equals to x raised to power x plus 3 raised to power 4. I now made it y equals u raised to power 4. Very simple. Now if I want to find the differential of this, or if I want to do the differentiation of this, I just do something like this. dy du dx. What is dy du? Is equal to 3 and 4 raised to power 3. Okay. What is du dx? 1. Therefore, dy dx is equal to 4 into x plus 3 raised to power 2. To confirm this result, we can expand. Expand this, differentiate this, and compare with the expansion of this. You will see that it is the same thing. So we have treated the chain rule for function of function, quotient rule, product rule, and we have gotten the standard result for y equals x raised to the power n. So from this, we can move forward and apply these rules to get other standard results or differentiation for other expressions. Now let's look at differentiation of trigonometric ratios. And for that, we look at the limit of sin theta over theta when theta tends to 0. Now, we can differentiate for trigonometric ratios when the angles are in radians. Please note, angles must be in rads. Now let's look at this. We have angle theta at the center. This is going to be r r. This is a chord. We are talking about a sector. Now, if I have this triangle like this, that is triangle OPQ. This place, the height will be this h, and from this you can see that h equals to r sin theta. So area of triangle OPQ will be equal to half. What's our base? R. What's our height? R sin theta. Half r squared sin theta. You get that? That is it. The next thing is, what will be the area of the sector? OPQ. You can see it's going to be half r squared theta. Please note, I said it. Theta is in rad. Now, for triangle, area of triangle ORQ is equal to half base. Now, what is this base? R and this base. And this is the relationship between the ends. Tan theta. So it's going to be half r squared tan theta. Now let's look at something. If you look at it, the area of this triangle is smaller than the area of this sector, and the area of this sector is smaller than the area of this bigger triangle. That is half r squared sin theta is lesser than half r squared theta is lesser than half r squared tan theta. If you are trying to find something, that is what will be the limit of sin theta over theta as theta tends to 0. That's what we are trying to find. You know, we have done that of when x tends to 0 in expression of x polynomials. Now, that is sin theta is lesser than theta is lesser than tan theta. Please, I want you to follow. It's a game. Just follow. I told you. Just like making you to enjoy the language of mathematics more. That is what calculus is for. Now let's find the inverse, the reciprocal. So we are going to have 1 over sin theta will now be greater, you understand, than 1 over theta will now be greater than 1 over tan theta. You know in inequalities now, when you divide, everything will now, the sign changes. Now with this, let's multiply 2 by sin theta. We are going to have 1 is greater than sin theta over theta is greater than cos theta. And you know one thing, when theta tends to 0, cos theta tends to 1. You can see. So as theta tends to 0, sin theta over theta will be bounded by 1 and 1 here. As theta tends to 0, 1 sin theta over theta 1. Therefore, sin theta over theta tends to 1 as result we are striving for. As theta tends to 0, sin theta over theta tends to 1. That's what you are looking for. From here now, we can now start working to get the derivatives of sin theta, cos theta, and tan theta, or any other trigonometric ratios. I have told you, you are very lucky to be part of STEM Cafe. Please, if you have not subscribed, kindly subscribe. Also encourage by making comments, liking, and sharing. Please, encourage us in any way you can do. It's welcome. Let us know whatever you feel like is wrong, and any question you feel like asking, go through the description. You will see the channel to do that. Let's continue. We have already established that as theta tends to 0, sin theta over theta tends to 1. Now, let's look at this simple expression. Where y equals sin theta. As theta increases by delta theta, y also increases by delta y. Therefore, we can also say y plus delta y is equal to sin theta plus delta theta. You can see. Now, let us now subtract this from this. We are going to have delta y is equal to sin theta plus delta theta minus sin theta. We have done this in trigonometry before, but I also try to, let's see how we can still do it again. No, I will just do it like division here now. For difference of two signs. You know, sin, okay, let me say sin A plus B is equal to sin A cos B plus cos A sin. Sin A minus B is equal to sin A cos B minus cos A sin B. Now, if I should subtract this from this, I'm going to have something like this. So, sin A plus B minus sin A minus B will be equal to cos A sin B. That's what it's going to be. But before we go on, let us make another, expression like A plus B is equal to B. A minus B is equal to C. Therefore, we can say, and from here, 2A is equal to D plus C. Therefore, A equals D plus C over 2. 2B is equal to D minus C. Therefore, B equals D minus C over 2. Just to refresh your memory. Now, let us plot this one here. So, sin, you can see sin D minus sin C is equal to 2 into cos D plus C over 2 sin D minus C over 2. Now we are bringing this one here now. It means that sin theta plus delta theta minus sin theta is going to be sin 2 cos sin theta plus delta theta plus theta sin theta plus theta minus sin theta plus delta theta minus theta. Let me write that out. Please, I hope you have noted this result. I hope you have noted it. Therefore, delta y will be equal to 2 cos theta plus delta theta plus theta. That is this one plus this one. Over 2 sin this one minus this one. Theta plus delta theta minus theta over 2. You can see the flow. You can feel the flow. Therefore, we are going to have 2 delta theta over 2 sine delta theta over 2. You can see. Now, let's divide through by delta theta. So we have delta y. Just like in the other forms, this is our main target. We are going to have this one to be cos theta plus delta theta over 2. You know this one. Multiplied by sine theta, sine delta theta over 2 divided by theta delta theta over 2. That delta theta, we use it here. The 2 that is here, I brought it down here. Do you understand? So that we will get similar result as this one. You can see. And you know that as delta theta tends to 0, this one is even getting smaller. It will be halved. So this one will tend to 1. And this one will give us 0. So, as sine delta theta over 2 over delta theta over 2 will tend to 1. So this one here will give us 1. Do you understand? And this one here will tend to give us 0. Is that clear? Therefore, delta y delta theta then is dy theta. And cos theta plus delta theta over 2 then cos theta. Therefore, dy theta is equal to cos theta. Please, I deliberately use theta so that we will not get confused. We are used to theta when we are talking about angles. So, you look at it as x. Sometimes it might be in terms of x. Anyhow, so if this angle here is in terms of x, we can say when y equals to sine x, dy dx is equal to cos x. Simple. That is the way it is. So add this one to your standard result in your special notebook. Now we have gotten that of sine. Let's look at that of cos. Let me put that one in terms of x. Let's say y equals cos x. Y plus delta y is equal to cos x plus delta x. Now, in the same way, we did that of the difference for sine. We will do that of cos here too. Minus cos x. And there is a standard result for this, just like that of sine. Okay, maybe I can just try to get it. Let's say cos a plus b is equal to cos a cos b minus sine a sine b. Cos a minus b is equal to cos a cos b plus sine a sine b. Now, if we subtract these two, I'm going to have cos a plus b minus cos a minus b will give us minus 2 yeah, sine a sine b. You get that? Minus 2 sine a sine b. And we have also observed that. Let's make it like this. Cos b minus cos c is going to be minus 2 into sine d plus c over 2 sine d minus c over 2. That is the result for this. So in the same way, delta y is equal to minus 2 sine x plus delta x plus x over 2 into sine x plus delta x minus x over 2. You get that? So what do we have next? It's going to be minus 2 sine 2x plus delta x equal to this one will be sine x plus over 2 minus sine over 2 divided by, and from the initial result we got, the limit as this tends to 0, this one will tend to 1. So as delta x tends to 0, sine delta x over 2 over delta x over 2 will tend to 1. So this is going to give us, and this one, you know, we have said that it will tend to 0, and delta y delta x will tend to y. Yes. Therefore, dy dx will give us minus sine x, because delta x over 2 will become 0. This one here becomes 0. So this is another standard result. Add it. You have gotten that of sine, you have gotten that of cos. Now let's look for that of tan. Now let's do differentiation of tan x. In this instance, we make it simpler by just using the quotient rule. You know that tan x equals to sine x over cos x. Therefore, y can be expressed as sine x over cos x. We try to make it simple. You know? Therefore, we can talk about dy dx as equal to cos x. What is the differentiation of sine x? That is cos x minus sine x. What is differentiation of cos x? Minus sine x again, divided by cos square x. Remember the quotient rule. Now, this is going to give us cos square x plus sine square x divided by cos square x. And that is going to give us 1 over cos square x. Simple. It's giving us 1 over cos square x. So this will lead us to x squared. So thank you so much. Add this one to the results you have. We will continue, and at least to the extent we can do in our own level. Kindly subscribe, I told you before, and so that the subsequent lectures, not only on this topic, we have so many interesting topics on every STEM subject, you will be quickly alerted about the dropping of the new lecture. Thank you very much. I appreciate you. Until next time, take good care of yourself.